My name is Robert Mannion, and I'm here today to present my company EverGreen Water Solutions and to talk about the issues that face manufacturers in Ireland for treating wastewater, industrial wastewater, and the challenges of meeting discharge consent. So this is just a little bit about my company. We started in 2008, and we specialise in industrial wastewater treatment, and we specialise in off-site manufacturing for wastewater treatment. And we offer technical and support throughout the UK and Ireland. This is just a little bit of a breakdown of the kind of business that we work on. We're a design and engineering business, so we produce full-scale installations for wastewater treatment for large industrial dischargers. So today I've put a presentation together for how to improve the operation of your existing wastewater treatment process and to meet a higher effluent quality standards, and give you an overview of what's required to meet these standards which the Environmental Agency will be bringing forward. So first of all, we look at the opportunity to remove biological particulate from the wastewater, which is usually done through screening. So what we put forward is that we look at always what is better for the end user. Is it to remove the biological particulate from the wastewater through mechanical or versus biological wastewater treatment? So what we've put today together is I've just shown you an inlet screen which is used in poultry processing, which contains very high fats, oil and grease, and also is used for recovering effluent from the birds to be reused in meat processing. This is also just another opportunity to remove solids from the wastewater. So we usually recover solids by using dissolved air flotation or using other means by removing particulate from the wastewater. This is also about recovery and making sure that there is an opportunity to recover oil, which is obviously a valuable asset to the food producer. And therefore, by removing the oil, you can actually have a water reuse and also reuse of the oil. So this is also just how the process works in regards to basically using the oil-water separation process. So again, anyone who has creating large oil and water mixing, we obviously want to recover the oil and then resell the oil. This is our next stage. Usually when it comes to wastewater treatment, we usually have biological treatment, and this is usually the next step after mechanical treatment. So using biological treatment, we use a process called MBBR or IFAS, and IFAS is a process that's been on the market for over 20 years and is a well-recognized process for treating of wastewater. This is just an example of the carriers that we use in regards to creating biofilm for the treatment of wastewater, and also the opportunities to retrofit biological treatment to existing plants. So it's all about really looking at the wastewater treatment plant that you have installed at the moment, and obviously increasing its efficiency and improving its effluent standards. So this is just to give you an example of what the differences are between MBBR and IFAS, and this will be more consistent with those who are familiar with activated sludge plants. So I've just given you an example of what the different process changes are for MBBR versus IFAS. So what it shows us here is that we've included the activated sludge return on the IFAS process, and we've just included a straight-through process with the MBBR. So MBBR would normally be used for the treatment of COD, which is usually necessary to treat through biological means. So this is the dynamic water phase that we call, which is about growing the biofilm on the carriers. And by having the biofilm on the carriers and increasing the surface area of the amount of area for the bacteria to grow, this increased the treatment capacity of the effluent plant. So what I've just done there, I've just shown you a little bit about the carrier, because people get an idea of what is a plastic carrier. or for this wastewater treatment, and it gives you what's involved in the treatment of using a biological carrier. So as you can see, there's like 20 years of R&D involved in the design of the carrier, and in regards to, and we use virgin HDPE for the production of the carriers. So this is just a little bit about what an MBBR reactor looks like on a wastewater treatment plant. So we've just given you an example of the benefits of using MBBR. So one example would be that you'd have a self-regulating biomass. So you can operate the process as a straight-through process. So for example, if you have a very high load from a dairy or something and you want to bring down the COD, you can just pass the wastewater through the reactor as a single stage and reduce the COD by over 70%. And this obviously is a big difference. This obviously is very important when it comes to your next stage of process. So flexible design flexible design and flexible in the organic loads. So obviously, this would mean that if you have different productions happening at different stages throughout the week, your wastewater treatment plant can cope with peak and variations in loads. So no operational adjustment, stable under large variation of loads, and a reliable and least operator intensive process. So obviously you don't want to have a dedicated person involved to the operation of the treatment plant. So this is just a little bit about the reduction of waste. So one of the big things that the majority of our industrial manufacturers are facing at the moment is the reduction in sludge and the commercial cost for the transportation and disposal of sludge. So one of the things that we always try to do is we try to look at reducing the volume of sludge to be disposed, and this is normally done through dewatering. So the commercial drivers are usually transportation, cost of disposal for landfill, and obviously environmental compliance as well. And obviously the big factor that we would have in regards our technology would be the amount of energy that's required to dewater the sludge. This is just a little bit about the process. You're talking about multiple process steps in regards to how the machine operates. You have flocculation, thickening and dewatering, and therefore obviously a very user-friendly piece of equipment. This is just a cross-section of the drum of what is inside the drum and how it works. So where the sludge enters, obviously at the sludge inlet, you've got your thickening zone and your dewatering zone, and then obviously you have a single end plate which is used to compress the sludge out. So a very simple straight-through process, and this would be a product that we have successfully installed across the UK. This is a little bit about how the machine works in regards to having a clog-free structure. So we've got moving discs and fixed rings, and by the moving discs and fixed rings we create this clog-free structure, and this allows us to dewater sludge which contains very high fats, oil and grease, so places like abattoirs, poultry processors, dairies, etc., etc. This is just an example of Richard, our sales director here, standing beside the machine just to give you a scale. So, and also how the screw is designed inside the drum. Obviously we use a tapered screw, and this gives us very high pressure on the sludge also on the rings. And finally what we have is we have tertiary treatment, and tertiary treatment is involved for the final polishing of the effluent before it's discharged to surface water. So the Environmental Agency have obviously been bringing in tighter consents for phosphorus and nutrients. So looking at taking out particulate phosphorus in the wastewater is really important, and this gives us a very simple process that can remove phosphorus and other nutrients from the wastewater. This is just giving an example of the machines that we would sell in the UK in regards to disc filters. So this is just some of our concrete installations that we've installed, and obviously we do sell them in stainless steel as well. And that's my presentation, and thank you all for listening.